Welcome everyone. I see we have some people watching. That's good. More fun that way. So this is the presentation SQL Server Worst Practices. I'm Magnus. I am a SQL Server specialist. That doesn't mean that I'm very good. Some people think I'm okay, but it means I'm even worse at most other things. So SQL Server is what I work with. And I've done so for, I'm so used to saying 20 years, it's now 25. And for the past 10 years or so, I haven't done anything else. I used to be a half bad .NET programmer, but these days I can sometimes read the code, I can't write it. So SQL and PowerShell is what I use for everything. There is a reddish box on this screen with a link to my GitHub account, and that's where you will find this presentation and other presentations, both the PowerPoint and the demo code that I will be showing. So if you're interested in playing with it, feel free to just download it. I think that's all. Maybe the last sentence here, maker of mistakes. It's what we do, I guess. It's how we learn. And I've learned a lot, so that probably meant I made a lot of mistakes. And that's kind of the background to why I made this presentation.
Quick interruption.
Yeah.
There's a saying of how you become a senior DBA, right? The way you go from junior DBA to senior DBA is you accidentally truncate a table in production and then you bring it back, right? So the only way to become a senior DBA is you have to make a mistake and then fix it.
Yeah, and I mean you're either out of a job or you learn something. So if you don't fix it, that will mean you won't become the senior DBA. But
it's a resume generating event either way, right?
Yeah. But yeah, that's pretty much how I learned. We'll get to it in the presentation, but making like dreadful mistakes was the way I learned like how does a restore works. Yeah, I had to mess up production data to have to do a restore and try to do a restore of a specific table, and you know the things we end up doing when we mess up. So the first part of the presentation is a bit developer oriented, and it will be some tips and tricks on how to make the code really slow and hard to maintain. And maybe the takeaways are the other way around. What can we do to not make the code really slow and a little bit easier to maintain? But the things I've done over the years and the things I still stumble upon when I see production databases where I come in as a consultant, they really took some of my advice about making the code really hard to read and run really slow. So we will look at a couple of examples of that. And the first thing you can do if you really want to make SQL work slow for you is to bring all of your C# knowledge into your T-SQL programming. So for example, code reusability is what we learn if we come from the C#, Java, C++, whatever programming language background. We probably learned that we should create functions for things that we do over and over again. And so in SQL Server 2000, we got user-defined functions. And I was the first one to just jump on them. I implemented user-defined functions everywhere. And all of a sudden, the databases performed horribly, like 10 times slower, even worse for simple things. Because of the nature of user-defined functions. Now, Microsoft has made some efforts to make user-defined functions inlined into the execution plans so that they can be optimized. But it doesn't always work, and if you're on an older version of SQL Server, like 2017 or older, you won't get the UDF inlining, user-defined function inlining functionality. So that means the function in itself is going to be a black box. The optimizer has no idea what the cost of calling that function is, and it has no way to like incorporate the logic of that function into the execution plan of the query that calls the function, which means essentially it's going to be called for every row in whatever operator is using it. And that's not really what a relational database is made for. It's made to work on sets, and if you feed it row by row, it's not going to be really fast for you. But that's one of the mistakes I've made, and a mistake that I see quite often, where SQL Server 2022 mitigates some of it, but there are times when if the function, for example, calls a get date function or something, it's going to be the UDF inlining is not going to work, so then you will still have a problem. And in a demo pretty soon, we're going to look at how we can change our functions to make them inlined in our code without relying on UDF inlining in SQL Server. Another thing that I mean, as developers, we want to be in total control. So how about we use cursors because we don't trust SQL? That's also kind of a rookie mistake. I see a lot of cursors in code that is written by T-SQL beginners. So define a cursor. A cursor is it's what it sounds like. Basically, you define a query, and then for every row in the result set of that query, you do something. So you loop over a result set using a cursor. And there's no way that you will be able to make that run faster than if SQL Server uses its own internal cursors or ways of iterating over a data set. So that will make your code quite slow as well. It's a nice way if you have a server and you want your manager to get you a bigger one, then start using cursors, because your code will be slow and you can tell him or her, give me a faster server, please. But the problem is that your queries will still be slow, so you'll have to be ready to also fix the code anyway. Another thing is that business logic should be in the application and not in the database. That's a common, I think, misconception, but it's kind of an architectural pattern to not put any business logic in the database. And then we need to create our annual reports. And I was involved in a project. It wasn't my fault to begin with, but the way this project worked. We had a database with basically two big tables, one 7 billion rows, the other one was around 4 billion rows. And we were doing reports on exports and imports of goods and services to and from Sweden. And we had data from 1980 and onwards. And the way the reports were built were bring in one of the tables, bring in the other table, and then internally in the backend loop over the result set and do calculations and fill in a report on the way. And when we were up to 5 years worth of data, it took like 24 hours to run a report on the full time frame. And we were going to do it for 30 years or something. So we needed, if we would have continued with the same architecture, we would have needed probably, terabytes of memory in the backend servers because they pulled in so much data from the databases. And really just letting your backend handle all the logic is not the way to do if you really want great performance. And I mean, there are other reasons why I think this architectural pattern is just plain wrong, because when you create your database, you will create a schema, you will create data types, you will create names for entities, you will create names for attributes of objects. And that is business logic in itself. So as soon as you have a relational database, you have business logic in the database. So there's no clear cut of moving all the business logic to the backend, because the only way to do that is to only have a key value store, and that won't make your application run fast anyway. But if you follow this blindly, that's a really clear path to horrible performance in both your application and your database. So I saw Jeff Moden leave a comment on Hugo's talk. I don't know if he's still around, but he coined the phrase rebar, and that's row by agonizing row. And it's really a mistake that many beginners do. Like, you want to be in control of everything, so do something with every row that you see in the database. Create even your T-SQL code in a way that it will look at each row and do something with it, instead of using the fact that a relational database works really well with sets, and it works quite poorly with loops and such constructs. I have one silly example and one more common example in the demos of using cursors and how we can mitigate using cursors or rewrite our code so we use a set-based logic instead. So let's look at some scalar UDFs and some cursors first.
Magnus, Jeff is in a meeting and he thanks you for the mention.
All right. Jeff wrote and still is active on SQL Server Central, I think, and there are some really, really good articles on SQL Server Central. So if you search for Jeff Moden on SQLServerCentral.com, everything that is on there is going to be a really good read. I have created a database with just some basic data. We have a sales order table, we have some currencies and some currency rates, and that's basically all we have here. So let's start with a demonstration of how we can use a cursor to really slow down our application. If we want to figure out the average rate for each currency, and we want to be in total control, or we just don't know SQL that well, then what we will probably or maybe do is define a cursor that does a select from currency rates. We have some kind of temporary table so that we can store the currency code and the sum of rates and the number of them so that we can calculate an average afterwards. And as I said, this is a pretty silly example, but it shows how a cursor works and how it's not very good for you. So we create the cursor, we open the cursor, and we fetch from the cursor into some local variables. And then to not make it horribly slow, I'm using a transaction because I'm going to insert into my temp table for each step of the way. And if you don't use a transaction to do that, what SQL Server will do is for every insert into the temp table, SQL Server will harden the log. That means it has to do physical I/O to actually write to the transaction log file. Whereas if you're inside a transaction, a transaction will either fail completely or succeed completely. So then SQL Server will buffer the inserts into a memory buffer of 64 megabytes. And when that becomes full, only then will the physical write happen to the transaction logs. You will have much less physical I/O if you use a transaction. And even though this is a silly example, I would never do this. There are times when using, for example, a cursor will be more readable for a junior DBA or a junior developer who has to maintain the code afterwards. And if that's the case, then this is a pretty good tip to use a transaction, even if it's something where you don't really need the atomicity that a transaction will give you, because it will boost your performance if you need to do inserts or updates or deletes to a temporary table or some other table with every loop step. Anyway, for each currency rate that we find, we're going to do a merge with our temporary table. And we'll basically update the rate count with 1 and we will update the sum of rates with the currency rate of the current row plus the sum of rates that we already have in the temporary table. And then by the end, we do some simple calculation. So I reiterate again, this is a silly example, but it shows how bad it can be performance-wise, and it shows how a cursor works. So we run this. It's not going to be very fast. Hopefully my computer will survive this operation. It doesn't always work well with a Teams or Zoom meeting, but it took us a good 10 seconds to do this. And we're not going to look at execution plans because there will be one for each insert. But it's a slow way to do an average of currency rates. So in this very simple case, we would instead just select the currency code and the average of the currency rate and group it by the currency code. And we'll get the results in milliseconds. So let's look at a less silly example maybe. When I did more of T-SQL training, let's move further down here to the good example instead. When I did some T-SQL training, the training material from Microsoft always said that we should try to apply a set-based approach to the problem solving we have. And then they gave an example of how we could generate a date dimension for data warehouse. And they did it by looping over all possible dates. And, not very good. So the way they did it is basically they defined a start date and an end date. And then as long as the start date is smaller than the end date, they did an insert into the dimension table with some values where they did some date part and such calculations. And then they added 1 day to the start date. So that's the way that the Microsoft examples worked for generating a date dimension in the data warehouse. To make it extra slow, they didn't use a transaction for it. So I wasn't showing that to my students. Instead, I showed this. I create my dim date table. I declare a start date and an end date. And then I select, and let's go to the from clause first. Oh, there we have it. From generate series. Generate series is a new function that we got in SQL Server 2022, which will just generate a number series for us. And it starts with whatever parameter you give first, and it gives you this many, or that's the max value in the series, and then you have the increment number. So if we just run, let's move up here. Select star from generate series from 0 to 100 and 1 step between each. That's basically what we get. And then I would use that. And for each row that I see in the result set from generate series, I add 1 day to the start date, or rather I add whatever value I see in the generate series result sets, that many number of days to the start date. And generating a date dimension with some 360,000 rows will be done only if I first create the table. Perfect. Let's rerun it again. I'm also creating a clustered column store index on the dim date. I won't discuss why, but I found that for a date dimension, it's a pretty good idea. But it's done in 2 seconds. And in the interest of time, I'm not even going to run this iterative approach of looping over dates. But it will take us a good minute or minute and a half. So 2 seconds, including creating a clustered column store index. If you don't have SQL Server 2022, you can still use a numbers table or a data set with numbers. You just have to generate it yourself. And the way I usually did it before working on SQL Server 2022 was by first doing just generating 10 numbers. So 10 rows, each with a number 1. It doesn't matter what value each of these rows have. And then I do a cross join between this first result set a couple of times. And this way I can generate 1 million rows, and I can use that for the rest of my query. So let's include also the variables. So by the end here, I do the same thing with date diff. I just generate the number of rows that I need for my interval start date to end date with 1 day between each, and I get the dates here. So 1st of January to 29.99. Well, it should be year end, so I need to add 1 more day. But it took 1 second to generate these 365,000 rows for the data mention. So either use generate series and use the fact that you have an ordered number of rows, ordered set of rows with 1, 2, or whatever you want to use between each of them, or use this cross join example to just generate a number of rows that you can then use together with the row number function to make them consecutive. That's cursors. Let's look briefly at functions. So in this database, I said I had currency rates. And one thing you usually want to do if you have currency rates in a database is to calculate whatever is this amount in US dollars, how much is that in Swedish crowns or Danish or euro or whatever. So I've created a function for that, a scalar UDF. I call it get amount in to currency. I will get a from currency, a to currency, a conversion date, and an amount. And this function will return this amount in this currency. And the way it does it is by selecting from the currency rate, joining to the currency rate. On the currency date should be the same in these 2 versions of the currency rate table. And the from currency code should be whatever from currency parameter I send in. The to currency code should be whatever to currency I send in. And they both should have this conversion date. So we create the function. And if I now try to use it in a query, we're going to do set statistics time and IO on. And I'm going to include the actual execution plan, or the execution plan with runtime statistics. And so I'll look at all the orders from the sales order table where the order currency is Swedish crowns, and I will convert the amounts to US dollars. So let's start with that one. And it's not going to be super fast. And there, not only is it not fast, but if I look into the execution plan, I will see a clustered index scan of the sales order table. And that's the only table I will see here. But I, who wrote the function, knows that this function will touch the currency rate table as well. So that's one problem with scalar UDFs before we got UDF inlining in SQL Server 2019 and 2022, is that we can't see what the function does by looking at the execution plan. And to find where the function call is actually happening, it's going to be in this stream aggregate. If I do the properties, and I need to move some mugshots around here, we have a defined value We can look at that. There we have it. And if I zoom into this, we will see that we have the call to get amount in two currency hidden inside the stream aggregate. So a pretty big part of the logic of my query is hidden inside a defined value inside my stream aggregate. Also, if you look at the estimated cost, it's 11%. But I myself, I'm pretty sure that it's going to cost more to join the currency rate table to itself and get the value for each row in the sales order table. Quite a lot more costly than scanning the sales order table. But the execution plan has no idea what this function does. So it will present it as just a function call with no cost. And therefore you won't get an execution plan that actually shows you what's going on. If you want to make things even worse, because I think this is bad enough that it took 9 seconds to run this query, you can also use this scalar UDF in the where clause. So if I only look at
Magnus, you're muted.
That's interesting. I must have touched my Jabra speakerphone. I hope you didn't lose too much of it. So I'm running this one where I have the function call also in the where clause, and now we're up to 13 seconds. And the execution plan is going to look the same, except we will have a filter. And if I'm not incorrect, it will call the function twice, both in the filter and in the stream aggregate. And also, if we look at the statistics for this query, the statistics IO, we will see that that's also a view that only shows that we're touching the sales order table. But I know for a fact that we're actually looking into the currency rate table as well. So what can we do to fix this? Well, first of all, okay, we have some more logic to it because not only is it performing bad, it's also producing the wrong results because there's not every day where we will have a currency rate. We may have sales on Sundays where the bank where we get the currency rates didn't update them, etc. So we can make this function a bit more complex. And what it will do is getting, if a currency rate is missing for a date, it will get the previous date instead. But let's skip that for the sake of saving some time and go into how we can make it function a bit better or perform a bit better. And it's pretty simple. We take the function code that we have in our scalar UDF. If the scalar UDF is simple enough to only have one select statement, which is quite often the case. And we change, instead of returning a scalar data type, we return a table. We keep our return statement. And what we return is the result of a select query. The select query is going to be exactly the same. So this function will produce a data set or a result set with one row and one column. So it resembles a scalar UDF quite a lot, but it will return a data set instead of a scalar value. And the trick is to make this table valued function an inline one, which means that we only have returns table. We don't define the schema of the table in our returns clause, and we don't do a multi-statement table valued function where we insert into a table variable and then return that at the end. Instead, we just return a table, and then SQL Server will figure out the schema of the result set. So let's create this function. And then we need to do some rewrites to the query that uses the function. So instead of putting the function call in the select list, we still select from a sales order table, but we cross apply to our function. And if you haven't used cross apply, the way to explain it is that logically, what will happen is that for each row in the sales order table or in the output from here, we apply this function and we make the results a part of the result set. So if this returns just one row, then that will just be a column added to the output. If it returns multiple rows, then whatever row I get from sales order will be multiplied that number of times. So let's try to run this with a inline table valued function, same logic as before, and it runs in less than a second. If we look here, it's going to be 638 milliseconds. And if we look into the execution plan, the plan will look a bit more complex. If we look here, the estimated subtree cost of the query will be a bit higher, but it will be more accurate. There may be other problems with this query, but at least it's not taking us 10 seconds. It takes us half a second instead. I mentioned UDF inlining. So if you're on SQL Server 2019 or 2022, you can just enable T-SQL Scalar UDF inlining on your database and then run the old query, the Scalar UDF. And it will run in 1 second, so not as fast as our inline table valued function. And the execution plan will be a little bit different, but still it will reveal the logic of the function, and it will inline that logic into the execution plan. So I would say this setting, alter database code configuration, set T-SQL Scalar UDF inlining, it will help a little bit or a big bit, depending on what the functions look like. And it's something I would turn on for a third-party system where I'm not in control of the database. But if I'm in control of the database, I would get rid of the Scalar UDFs anyway. Because
Magnus?
if the Scalar UDF is not deterministic, the inlining won't work for us. Is there a question?
Yes, there's a question, and I thought you were at the end of a sentence, but I was wrong.
No way.
Question, do you recommend to change all scalar UDF to inline table UDF with 1 row and 1 column, question mark?
Yes. Or find some other way of getting rid of them. But it's, in most cases, it's a pretty easy rewrite to take your Scalar UDF and make it into an inline table valued function. But then again, you have to also rewrite the code that uses the Scalar UDF to instead call the table valued function with cross apply or outer apply, whatever fits your use case. So it's not a snap of a finger to get it done, but it's most probably going to be worth it for you to do it. And you still have the modularization where you put your, the repeated logic into a function, so you don't have to repeat it in every time you need to use it. With that said, I've seen cases where we just enabled Scalar UDF inlining on a third-party database, and we got like 50, 60, 70% performance boost from doing it. But as I said, it depends on how the Scalar UDF is written, if it's usable or not. Because if it's not deterministic, for example, by calling current timestamp or get date, it won't work for you. Back to the presentation, which is over here. We are 25 minutes left, right? Or we have. More on developer things, naming conventions, because not only is it You know, we don't only want our databases to perform fast, we also want to be able to maintain the code. So one of the things I see and I have been responsible for is bad naming conventions. So for example, prefixing objects with the object type, TBL underscore table name, SP underscore procedure name, FN underscore function name. If I do a select from something, I already know it's a table. It doesn't have to be prefixed with TBL underscore. I created the object, I know what it is. So it doesn't help to name it TBL underscore. And to me, it just looks ugly. But it's basically up to you if you want to use this Hungarian notation, with one exception. But then if you have this naming convention and then you change it every year, but you don't update the old object, so you switch from camel case to Pascal case, etc., and then half the objects are with Pascal case and half the objects are with camel case, and so on. That's going to make me a very grumpy person if I need to do anything with this code, because it will hurt my eyes and I will make mistakes. So I'd rather have a team agree on a naming convention. If you are the only person on the team, still write down your naming convention in a document and follow it. And basically use any naming convention you want. I might not be as happy with it, but it's up to you. But never name stored procedures SP underscore proc name. It's ugly to begin with, but it will also come back and bite you. And it did bite me once. We had the naming convention, every stored procedure in the database was called SP underscore something something. Then we installed a service pack from Microsoft, and one of the stored procedures couldn't be called anymore. Why? Because in that service pack, an undocumented stored procedure was introduced. That's a procedure that lives in the master database. It was a system stored procedure, and a system stored procedure. There is a special case if you name your user procedure SP underscore, and the case is that if you get a system stored procedure with the same name, that procedure will be called, even if you try to call your own procedure with database name .schema .stored procedure name, etc. So we had to, you can't alter the stored procedure either, because then SQL Server thinks you're trying to alter a system stored procedure. Can't do that. So all we could do was drop it and recreate it with another name. That's when we changed the naming convention of stored procedures to not use SP underscore. I don't remember what the name of the procedure was, but something that made sense to be a system stored procedure. So also when you write your code, if you make it readable, not only by having a naming convention that doesn't hurt my eyes. One example is just don't nest ifs and else's in your code. I have written, unfortunately, stored procedures which are like 1,000 lines long, and it starts with an if statement and then 500 lines of code, and then an else statement and then another 500 lines of code. If you need that type of Boolean logic in the control flow of your stored procedure, make 2 stored procedures out of it, one for each case, and then have your control flow in a wrapper stored procedure that will do the if whatever value equals whatever other value, then call one of the procedures, and otherwise call the other one.
Magnus?
Yes.
There's another question for you.
Oh, go.
What is your recommendation to set different collations to different databases as business requirement? How would it affect temp table or table variable in stored procedure?
Good question. If you can avoid mixing collations on an instance, if you can't, which is often the case, then you would have to use like an explicit collate whenever you do stuff with strings. Same with cross-database queries that have different collations. And what I usually end up with is collate database default, which will give every object that I compare to the collation of the user database that I'm running the query from. I know that there is a difference if you're using a SQL collation or a Windows collation, how costly this collation conversion is going to be. I can't say from the top of my head the specifics, but ask Erland Sommarskog or read his article on the topic, and it will tell you all about it. So I would say maybe if you need to mix collations and you need to run queries that query data with different collations, make sure it's a Windows collation and not a SQL collation for performance reasons. If you have local variables or parameters in your code, please don't name them P1 or my local variable, etc. Give a meaningful name so that when I open your stored procedure to do something with it 10 years after you wrote it, I will at least have a chance of understanding what a parameter or variable is meant for, how it's going to be used. I didn't follow my own advice because I had a temp table named T. That's not a very good name in my previous demo. So don't do what I do, do what I say, maybe. Remove code that isn't used. Don't just comment out 400 lines of code in a stored procedure. That's why you use source control, so that you can remove code and then go back to a previous version if you need that code back. Switching tracks a little bit from development to DBAs. I used to be younger than today, and I used to be a developer. And I asked my manager, who is the SQL Server DBA around here? And he pointed at me and said, I think that's you. And so I was there with the responsibility, but without the knowledge of being a DBA. So I started doing some things. I looked at sizes of databases, for example, and I saw, there's a lot of empty space here. Let's do something about that. So I tried to get rid of all the free space in every data file by using auto shrink. That was an option, which was never on by default, I think, but it was there, and I didn't know what it meant, so I used it. That's, by the way, a good advice. If you don't know, then don't change. But I was young-ish and more foolish than today. And then I read on probably SQL Server Central that auto shrink is the evil of all evils. So I didn't use auto shrink. Instead, I created an agent job that shrunk all the data files every day. So that's basically the same thing as using auto shrink. If we did index maintenance, which took a couple of years before I figured out what it even meant, but doing index maintenance tends to grow the transaction log file. So what I did was, by the end of the index maintenance job, I did a DBCC shrink file on the transaction log to remove all the empty space, which meant the next time we had a transaction that did an insert to something or that needed to write to the transaction log, we had to grow the transaction log, and that's not going to be very good for you. So if we think about when it really will be appropriate to shrink data files or transaction log files on a regular basis is never, don't do it, not on a regular basis. Don't shrink the log file either. Don't even think about shrinking your temp DB. Even though I know Daniel Uthmacher has a blog post on shrinking temp DB, because in this one edge case, he really needed to, because he was out of space on a drive and it wasn't only for temp DB. But normally temp DB is going to be recreated when you restart the instance. If it fills up, it meant that some workload in your database needed space in temp DB. Likely it will need that space again, so don't shrink. If you purge last year's data from the database and you see a lot of free space, just leave it. Because unless you're going out of business, you will fill your orders table or whatever system again with new data. So don't shrink your data files, don't shrink your transaction log files. If you have a storage admin that tells you that your databases consume a lot of disk, you can respond, I know, or what about it? Or you can advise the storage admin to get more disks if they're running out of disk. Because I haven't seen an organization that freely gets rid of old data. They want to keep it, they hoard it, and as a DBA, it's your job to just make sure it works to keep it. So if you have moved last year's data into some cold storage of some kind, just leave the empty space alone, because otherwise you'll have to call your storage admin again and ask them for more disk if they reclaimed that space from the drive. So unnecessary bureaucracy. Taking backups, that's also something I learned when someone told me that I was the DBA, that maybe we should stop taking backups on our production box, because we didn't have backups on our production databases. Luckily, we didn't have a disk crash or something, but so I started doing backups. And I found out that being able to restore backups is a lot cooler than being able to take backups. So things to look out for: the backup job finished successfully. That doesn't mean you have backups, because if the backup job didn't do anything, you don't have backups. If you use, for example, Ulla Hallengren's database backup stored procedure, just look if it has user databases, system databases, all databases, or a specific set of databases in the job that uses this stored procedure. If it has a specific set of databases and you add a new database to your instance, well, then that's not going to be backed up, and that's going to be a problem for you. When you have taken your backups, where do you store them? Do you store them on the same physical storage as your data files? Then you might as well not have backups, because if that storage goes corrupt, your backups are gone. And where do you test your backups? And that's a thing. It really, really is. And I'm surprised when I see really big organizations in, every industry I've seen, where backups are taken. Maybe the backup job will do a restore verify only. That's not a real restore test. And then they never test their backups until they have a disaster in production where they need the backups. And then if they're lucky, the backups work, but they don't know. So it's really hard to keep an SLA unless you test your SLA from time to time by actually restoring the backups. We have 10 minutes left, so we have time for a little demo. And it's a fast one. So I create a database that I call DR. I create a table really important one, stuff that I don't want to get rid of. So immediately after I fill this table, I take a backup. And I do restore verify only to make sure the backup worked. And if you looked closely, you would see that I have my data files on this path, and I have, oops, my backups on basically the same drive. Fantastic, right? So now we have it backed up, and we get the disaster. And to simulate the disaster, I have my PowerShell script doing dr crash boom bang ps1. And we'll have to wait a little bit for our instance to come back up again. We can do a refresh here. And we see that the DR database is recovery pending. We can look into the log and we will see that it couldn't find its data files because we lost the drive where these data files are. And if we now look at the backup file we have, it's executing. Let's try again. It may be that my instance wasn't started yet, so let's see if that was the case. Cannot open backup device. Yeah, because it's on the drive that we just lost. So that's not good. And that would never happen in like a real shop where you have real DBAs, right? But the fact is that it does. I've seen third-party providers who do exactly this. They put the backups on the drive, or at least on the same physical storage device where the data drive is. And then they rely on something that goes on and offloads backups once per 24 hours or so. But that means you will lose up to 24 hours if you lose that disk. In a survey that is called the Proofpoint 2024 Data Loss Landscape Report, I don't think it's free to download. You'll have to pay a little bit for it. But if you're really interested in disaster recovery, then it's a good read. 85% of organizations surveyed say that they suffer data loss. I mean, it could be anything. A user accidentally dropped a customer or deleted a customer from an order system, or it doesn't have to be the DBA's fault. But it led to permanent data loss in so many cases that 35% of the companies were issued regulatory fines because they lost customer data that they really weren't supposed to lose. And if you don't have a good disaster recovery plan and you don't do your restore tests, you will be one of those companies that lose data permanently, and you will lose customers, you will lose your reputation, and if things go bad, you'll get a big fine from, for example, the EU. If you're in the financial or insurance business and you lose customer data, you will be fined pretty severely for it. So don't do that. Test your backups. Make sure you store them in a safe place. And that safe place could be, far away, you may think, or at least somewhere else on a different type of storage than your data drive is. The routine we had when we actually started testing backups and thinking about disaster recovery scenarios was that I sat on my bicycle, went to work, went to the data center, took out the tape from the tape drive. As you can imagine, this was not yesterday because I said tape drive, but that's how we did it not too many years ago. I took the tape out, I sat on the bike again. I went home and put it in my bedroom drawer where I had yesterday's tape, which I took out, went back to work, put it into the tape drive. That means we had a copy of the backups somewhere else than the data center. So if the data center is set on fire, we would at least have a backup that was less than 24 hours old. It's not a perfect disaster recovery scenario, but it was better than doing nothing. And these days, when you have cloud providers, and it's pretty easy to send, if you're using Azure for your databases, we'll put your backups in AWS or vice versa. It's not that hard, and storage isn't really expensive. So that's a pretty good insurance for you. And then if you need to do it with also every transaction log backup, or if it's enough to do it with a full backup every 24 hours, that's up to you and your discussion with the business users about SLA. But make sure you know that you can follow the SLA, basically. 4 minutes, cool. As I said before, if you don't know, don't change. So if you Google for some advice and you found an answer to your question, and you don't really understand the reasoning behind the answer, then that means you still don't know. So hands off. Don't end up doing what I did when I was a junior DBA. I changed database recovery model without knowing what it meant. Back then, it wasn't called simple recovery model. It was called truncate log on checkpoint, and it sounded excellent. So I did that to all of our databases. And all of a sudden, our transaction log jobs ran really fast because they didn't actually back up any transaction logs. So not good. If you don't know what fill factor means for indexes, well, don't change it. If you know what it means, well, maybe change it if it's appropriate. I tried changing delayed durability on a database once as well without knowing what it meant, because I saw some advice that it would make hardening the log faster. But what it really means is that the log isn't hardened when the transaction commits. It will happen eventually. So if you have a disk crash after you committed your transaction, that transaction may still be gone when you restart your service. So I touched these settings without having any idea what they did, and there are quite many settings on a database and on a SQL Server instance. And if you don't know what they mean, then don't change them. But by all means, do figure out what some of these settings mean, because the default settings by doing a next installation on SQL Server isn't perfect. So look at the max.dop, figure out what it means, and then change it. Look at the cost threshold for parallelism. And once you understand what it means, you probably understand why you would want to change that. Look at the auto growth settings for a database. If you just do create database without any options for auto growth, you will have really tiny increments of auto growth for the transaction log and the data file. And that's going to hurt you in the end for many reasons. But figure out what these settings means and call someone who knows if you don't know. If you find yourself to be the junior DBA like I was and you have no idea what to do, but you have the responsibility to do it, get your manager to pay for, it doesn't have to be a full-time senior DBA consultant. Get someone that you can ask questions once a week for an hour and get some good advice, and have maybe someone externally prepare a disaster recovery drill for you so that you can test your own disaster recovery procedures. Because the things you missed, you won't create a scenario for that, but someone else might spot it and create that scenario for you. That's what we have time for. There's some more content, but it's more of grandpa yelling at young people. So I'll stop here.